Hello, ninth grade. I would like you to this weekend work on section B of those sticks, or there are 2 sticks, and see what you can make of those. Don't spend a lot of time, maybe half an hour on those. And I would like to talk to you about what happens when we have 3 points, a triangle. And you can imagine if we're looking at the triangle from the front, it might look like this. If we're looking at it from the front and it looks like this, we can actually see it. When we look at it from the top and from the sides, we're only going to see a line, right? And if we remember what we talked about, the triangle from the front is going to look actual size because all the lines are parallel to the front of the box. And the line, the single line that we see from the top is going to be actual size because it is parallel to the top of the box. But the 2 sides, and we'll only see one of them from the side, we'll only see one of the lines of the triangle from the side, it will not be actual size. It will look foreshortened because it is not parallel to the side of the box. So you have to imagine us moving around this. Right here is, if this is the front view, this is going to be the top view. So front view, top view. What's the side view going to be? This is going to be the side view. So if we were to quickly draw that in our boxes without worrying too much about the relative proportions, that would be the front view. That's what we would see from the front. From the top, we would see this line, which is actually, if we're looking at this and we see this line, it's the top of the triangle that we see. This line right here is going to be this line right here, and it's going to be actual size. It's going to be the same size as the top. But when we get to the side view, we're going to see a foreshortened line, but it's going to be a straight line, right? It's going to look like this. It's going to kind of look like this because it's actually going away from us, if you can imagine that. Because we're looking at it from the side and it's going, you see the side view is going away from us. So it's a little shortened in that way. It might be a little longer than that. So I'd like to look at this, another version of this, looking at the actual box, so we can see 3 views from the actual box. And then we'll practice with this, with our orthographic view a little bit. So if we look at this, the front view, this is actually an equilateral triangle, and it's slightly tilted down. So in the front view, it looks a little distorted. It doesn't look exactly like an equilateral triangle. This is the top view. And from here, it looks a little less distorted because it's almost, but not quite parallel. So it almost looks like an equilateral triangle. And you can see from the side view that it is a straight line. It looks like a straight line. So I hope from the top, the side, and the front now we have a perspective on, that's a pun, a perspective on this equilateral triangle hanging in the viewing box. So here's our orthographic projection of that triangle, that equilateral triangle, hanging down in the box. And remember what we said, when we look at it from the front, this line is parallel to the front of the box. So this is actual size. And this line is parallel to the front of the to the top of the box. So it is actual size. The same line actually is parallel to both parts. And so we can find that side view that we saw in the same way, right? We have 3 points, right? We have point 1, point 2, and point 3, and point 1, point 2, and point 3. And those points, again, point 2 is directly above point 2 from front to top. 1 is directly above 1 from front to top. 3 is directly above 3 from front to top. So just like we did with the sticks, we make a line, and 2 and 3 are in alignment here, right? So we can come straight across from 2 and 3. There's that. And 1, we can come straight across from point 1. There's that. And then up here, similarly, we come straight across from point 2 and 3. Here we go. And then we come straight across from point 1. There's that. And then we need our compass. We need our compass, and we can make the swoops from 2 and 3. We put our point here. Put our compass up here by 2 and 3. Make sure we're in the right spot, and we are. Compass walk again. We make our swoop to 2 and 3. There it is. Comes all the way over there. And then we have to make our swoop from 1. Here's 1. Yeah, there's 1. The compass is walking around again. There's our swoop to 1. And so then we have to bring those down, just like we did with the other one. Here is 2 and 3 coming down. And here's 1 coming down. Oh, gotta get that lined up a little bit better. Here's 1 coming down. Right? So here are 2 and 3 coming across. And here's 2 and 3 coming down. So they are right there. And here's 1 coming down and 1 coming across that's right there. And so our side view, which is exactly what we saw, is this diagonal line going like that, which is not parallel to the side, right? Because it's actually going in, which is why if I measured this, actually, the lines that are actual size I made them here 3 inches. So that one's 3 inches and this one's 3 inches. But none of the other lines are 3 inches. This one's only 2 inches. And these are only an inch and a bit. And these are 2.5 inches, right? So the only 2 lines that are actual size are these 2 lines that are where the line is parallel to the top and parallel to the front. And so there are our 3 views in the orthographic projection that we saw in the viewing box. And so now we're going to work in class on problem set C, which is dealing with some 3D figures like triangles and other things. And then after that, we're going to work on plate number 2, which is for you to pick an orientation for your triangle and do the 3 views. And I will talk about that more in class.